In the year 2525, the Earth is no longer the world we once knew. What remains of our familiar landscapes, city skylines, forests, oceans, has been radically reshaped by 5 centuries of relentless change. Yet, amid ruin and rebirth, there lies a secret. Life, as fragile as it once was, has found ways to persist, in forms we never could have imagined. We open on a silent skyline where skyscrapers, now skeletal frames rising from glassy waters, glint under the pale light of a rising sun. Waves lap against concrete towers that used to house millions. This is Earth, 5 centuries after the tipping point. Sea levels have surged, coastlines have dissolved. Yet, where humans once built concrete cities, watery forests now flourish, mangroves reclaiming steel, algae carpeting submerged plazas, coral reefs blossoming around sunken highways. The world of 2525 is both ruin and renewal. This is not merely a tale of catastrophe. It is a story of transformation, of how climate change, over centuries, has remade the planet into a new, living mosaic. Our journey begins with a reconstruction of the past, 500 years ago, when heat waves, floods, and storms first began pushing the planet into a perilous new equilibrium. Scientists now refer to that era as the Great Acceleration, the point at which carbon emissions surged beyond every previous threshold. Archival footage, preserved in digital vaults, reveals coastal cities in turmoil. Flood barriers fail. Delta regions become uninhabitable. Populations migrate inland or to high ground. This mass displacement continues for decades, triggering geopolitical upheavals, economic collapse, and societal fragmentation. But this is only part of the story. Over hundreds of years, Earth systems begin to reorganize. Geographers and climatologists trace how the melting of Greenland's ice sheet triggered changes in ocean currents. Without the powerful flow of the Atlantic meridional overturning circulation, the climate of Europe shifted. Winters became brutal, summers unpredictable. In parallel, other regions scorch under unrelenting heat. Equatorial zones, once lush rainforests, transform into desert-like expanses. But even these extremes find a strange balance. Life adapts, ecosystems reassemble, and in this sprawling, new climate world, there is reason for both dread and awe. Beneath the surface, a remarkable renaissance. Sunken skyscrapers serve as the foundations for massive coral reefs. Hues of electric blue, salmon pink, and deep violet grow around girders and broken glass. Schools of fish swirl through abandoned highways. Giant seaweeds drape across former office floors, sea turtles nest in the nooks of broken concrete. In these submerged ruins, marine biologists, remote-operated vehicles equipped with advanced sensors, map out new ecosystems. These oceanic jungles teem with life, mollusks with bioluminescent shells, plankton that glow in shifting currents, and crustaceans sculpting living structures from coral skeletons. Research teams speak of an ecological alchemy. The very ruins of civilization are repurposed by nature. What humanity destroyed, nature reclaims, but not as before. It builds something completely new. Meanwhile, on land, formerly forested regions have dried into windswept deserts. The camera sweeps across dunes that ripple like liquid gold under a blazing sun. Ancient trees lie fossilized beneath the sand, reminders of what once was. But it's not all barren. Amid these deserts, scientists and engineers develop geoengineered oases, pockets of shade where genetically modified flora thrives. These plants have been altered over generations to survive extreme drought, to root into hard-packed sand, to harvest every drop of moisture from the rare desert storm. At nighttime, the oases glow softly, bioluminescent shrubs casting emerald light, engineered fungi glowing in blues and purples. These are the desert's beating hearts, sanctuaries of life in a sea of sand. Expeditions chronicle nomadic communities that have adapted to this harsh existence. In translucent domes built from lightweight ceramics, people live and farm. They cultivate crops bred to require minimal water, harvest air moisture, and use solar reflectors to shield themselves from searing winds. One of the most startling changes is overhead. The sky itself has transformed. Because of persistent particulate pollution and aerosol geoengineering efforts centuries earlier, the color and behavior of clouds have fundamentally changed. The atmosphere, thick with microdroplets, refracts light in unfamiliar ways. Sunsets now bleed into deep crimsons, purples, and golds. The clouds, once white and fluffy, shimmer with iridescent pastel sheens. At night, the sky pulses with spectral auroras in mid-latitude regions, the result of increased solar radiation interacting with altered magnetic fields and now changed atmospheric chemistry. Electrical storms crackle with bizarre color patterns, violet lightning, copper-hued arcs, and thunderstorms that hum like distant machinery. Satellite surveillance continues, through floating solar platforms, to monitor these atmospheric changes. Meteorologists describe the sky of 2525 not merely as weather phenomena, but as a new planet signature, the visible breath of a world remade. Humanity did not disappear, it adapted. Where seas rose, buoyant cities float. Modular platforms, made from advanced composites and biofibers, drift on the waves. They cluster like giant lily pads. In these floating metropolises, children grow up knowing the rhythm of tides. Their buildings sway gently, rooted to underwater pylons, and energy is harvested from waves and sunlight. On high plateaus and mountain ridges, new towns emerge. These are places once deemed inhospitable, thin air, steep cliffs, and jagged terrain. But they are safe from deluge. Here, people live in terrace dwellings carved into rock faces, with vertical farms clinging to cliff walls. Wind turbines spin on ridgelines, and glacial-fed streams run through aqueducts, delivering water to hanging gardens. Below, in the ruins of the old world, a global network of researchers and historians records and preserves. They harvest data from ancient buildings, reconstruct pre-climate change societies, and archive memories of the old Earth. Virtual memory pods allow people to experience landscapes that no longer exist, forests that now lie buried beneath sand, lakes that vanished centuries ago. There is grief. There is longing. But also ingenuity. And a new collective identity. We are no longer just survivors, we are custodians of a remade planet. Over centuries, life has not only survived, it has evolved. In labs suspended on floating platforms and hidden in mountain laboratories, biologists have bred new variants of plants and animals. These lineages are sometimes the descendants of species that nearly vanished during the climate turmoil. Take the desert woodlark, for instance, a bird engineered over generations to survive scorching heat, with translucent wing feathers that dissipate radiation, and eggs that can withstand temperature extremes. They nest in the rocky deserts, singing melodies that drift on hot breezes. In waterlogged zones, amphibians with thick, scaly skin now leap between floating islands. Their skin secretes moisture-repelling oils, a trait selected to avoid dehydration. Coral reefs, once dominated by a handful of species, now host biodiversity leagues richer than ever. Fish with neon patterns, mollusks that build their shells in spiral geometric structures, and seaweed that glows in the dark. Forests, too, have returned in surprising forms. In former temperate zones, bioengineered groves consist of trees with interwoven root networks that share water and nutrients, even across species. These networks form vast wood webs, living circuits of life, resilient to drought and fire. Scientists document how these new ecosystems operate not just as collections of species, but as dynamic systems, living machines shaped by 5 centuries of natural selection and human-guided evolution.